Hey everyone, we're going to talk today a little bit about graphs of functions. So corresponds to section 2.2. In the homework for 2.2, you're going to answer a bunch of questions regarding reading graphs. So remember that the graph of a function is a collection of ordered pairs or points. Each one of them has an f value, an x value, and an f of x value, which we usually refer to as a y value. So each one has a domain and a range. Domain, again, is your legal input values for x. Range are the y values or the f of x values that come back out of the function. So if I'm looking at some examples of graphs and determining their domain and range, looking at this first one, the domain are all the x values that it achieves. So it starts here at -2, but does not include that -2 value since we have an open circle. So if I'm doing this in interval notation, I'd use a rounded parenthesis and start at -2. Now it goes in x direction all the way to 4, and the 4 has a closed circle, so we're going to include that value for the domain. So here's our domain. If we're looking at the range are values of y that we attain. So when we talk about the range is the lowest value of y to the highest value of y. So it's a little weird because we don't start at our value most to the left and go to the right. We start at the bottom and go to the top. So here is our bottom most value for y, and it corresponds to -5. Now it includes that value, so I'm using a square bracket. Moving to the highest value of y that we attain, this is the value of y. It doesn't correspond with a nice 3, but handily we have the ordered pair here. So it goes to 3.1430. Also inclusive because we have a closed circle. Now, if we want to find the function values f of -2, what it's asking us for is what y value comes out if we put in -2. So at -2, you see that we have this open circle here, and we don't have another closed circle on this line. So really at -2, the function does not exist. I'm using DNE for does not exist. F of 1, if I were to plug 1 into this function, 1 corresponds to this value here. It's almost 1, but not quite. I'm going to call it 0.9 as an estimate of y. Looking at f of 3, if we were to plug 3 in for x, what do we have for y? I'm going to say it's almost 2, so let's call it 1.95. We're pretty close. Either way, those are values of y. The height values are f of x. Looking at this next function, this is shaped like a parabola, like an x squared function, but it's got a hole in it. So if we're going to look at the domain, the hole means that we do not have a definition of a function there. So that's at the point x is equal to -1. So my domain for this function goes from -infinity. We're assuming this continues on because it does not have some endpoints on it. So -infinity to -1, but does not include -1. And then from -1 to infinity. Range, remember we're talking about the lowest point that y attains. So it looks like -3 here. And it does actually achieve it. And then it goes on in the positive direction to infinity, so we're going -3 to infinity. Infinity is always a rounded parenthesis. We'd never include it because it's not an actual number. Plugging in those values, f of -2, tracing that up, looks to be about 5 and 5.8. Almost 6. F of 1 is our vertex point, our -3. And f of 3 looks like 1. Now these two graphs are graphs of functions, but a graph doesn't always represent a function. We saw one in an earlier section that looked something like this. This is not the graph of a function. So no. We will have a section later on in the semester where we deal with all graphs that are not functions. Now, to tell if something is a function, we apply what's called the vertical line test. So if you can draw a vertical line anywhere on a graph and it hits the graph more than once, then that is not a function. So if I'm looking at this, for example, if I draw a vertical line here, I'm hitting the graph 2 times, so it is not a function. Same thing is true with a circle. Now remember, a circle is an equation x squared plus y squared equals r squared, centered at the origin. So if I were to try and solve that for y, I would get a plus and minus case. So we cannot solve it uniquely either. So this is not a function. Looking at these top two, no matter where I draw a vertical line here, I'm only hitting the graph once. So this, by the vertical line test, is a function. Same thing is true here. No matter where I draw this line, even though it gets steep toward the edges, no matter where I draw that line, still only hitting it once. So we do have a function here. Now the zeros of a function are the f values when x is equal to 0. So, or are the x values for which f of x is equal to 0. So if we are to let the y value be 0, then we solve for x to get the zeros of the function. So set f of x equal to 0, and then solve for x. And that's how we find our zeros of our function. Now, if I want to find the intercepts of this function here, if we are looking at the graph, then I have intercept points here and here. Those are my intercepts, or my zeros. These ones are the ones where my y value is going to be 0. I also have an intercept point here. So that's my other point based on the graph. Now remember, we learned in an earlier section that we can plug in 0 for x and y to find our intercept points. You'll have to identify them on the graph for this section, but you will not have to plug them in here. Now this function is a cubic function, but the x value is squared inside. You see that it has 3 separate intercept points. 2 of them are zeros, 1 is a y-intercept. You can estimate these points if you are looking at them. This one also only has 1, so 1, 0 here. All right. As you go through the homework for this section, you are going to be analyzing graphs. As usual, if you have any questions, please feel free to reach out. I'm happy to meet to go over any problems that you have. Have a great day.